Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our online certification courses on engineering drawing and computer graphics. We are covering module number 7, which is about computer graphics. In computer graphics, we mainly cover overview of computer graphics, how they have originated and what are the commonly used softwares, little bit about AutoCAD and in detail about SolidWorks. These are the modules what we will cover in computer graphics. In terms of overview, so till now we have learned how to draw technical drawing on sheets using dimensions, compass, dividers, scales, protractor and other objects we have used. Try to construct two-dimensional and perhaps three-dimensional objects in isometric views. Now onwards, we will try to use computers how to construct such kind of three-dimensional objects or perhaps the cut sectional views of three-dimensional objects. To begin with that, first we will look at some overview on these computer graphics. So, the modern days engineering designs always involves three-dimensional objects and 3D solid modeling. For example, here these are the views what usually we construct it on sheet, our drawing sheets. Perhaps right side views, left side views, top view, front view we construct. Try to imagine how an object really looks like in 3D and try to represent that in isometric views. The advantage of these computational graphics is they look nice and over that precise dimensions we can always use. Whenever you are drawing sketches, there always be least count, whereas at computer graphics you will have precise information. Although the shaded portion like bright, light colors, dark colors, this kind of things gives nice appeal to eyes. The real power is about precise and unambiguous description of the object, and all that information we can store it in the computer. Even after 10 years, if one would like to recover that information, we will be in a position to use that. Whereas a drawing sheets and other things what manually we do, they have a lifetime. And further, if we want to share that information with others, that can be also possible for the supply chain. So, technical drawings will be prepared at one place and that will be supplied to different teams, and this is the easiest way of transferring information from one location to other location in the supply chain. Usually these computer graphics involves effective use of graphics as a tool for visualization of design ideas. We first try to construct on two-dimensional sheet, interpret that and from there finally construct that 3D objects. The other advantage of these computer graphics is, if one would like to quickly prepare a prototype, it is quite easy to use these drawings. These days people are going with 3D and the advances like 4D printing. In 3D printing, if you can supply these computer graphics, the complete design of that object, the machine will be in a position to print that object in a very effective way. So, if one is interested in preparing very quick prototype. The typical softwares like AutoCAD and SolidWorks, there are other softwares also like CATIA. These are the ones which one can really comes as handy. Till now we have learned about 2D drawings. Mainly those 2D drawings are helpful in terms of understanding kinematics and to check position of circuit elements or perhaps for the point of blueprints. These are just a documentation to give us easy information. The detailed information we will get only through 3-dimensional modeling. Especially the 3-dimensional modeling consists of 3 different varieties. One is wireframe model, other one is surface model, the third one is solid model. Before really looking at these softwares, a overview always help us to remember certain keywords of this technical drawing. For that purpose, we are covering these brief overview on computer graphics. Okay. The first wireframe model are used as input geometry data for easy analysis of the work. Here, a picture of bridge is shown. If you look at carefully, it contains many line elements. It looks like a wireframe. So, the skeleton of the object we always get it from this wireframe, and this wireframe has to be supplied if one is interested in designing an object. For example, all these civil engineering problem, aerospace engineering problem, chemical engineering, mechanical, electrical engineering, they mainly work on continuum mechanics principles. There will be fields, information about stresses, strains, temperature, perhaps the information about current and many other things we usually represent like fields. That means, at each and every point of the system, we will be in a position to really identify that particular information. For that purpose, usually when we are writing programs or perhaps solving partial differential equations, to understand those essential physics issues, we have to supply the object in a wireframe model. For example, like you have a cell phone, there might be a chip processor, it is continuously exchanging energy with the surroundings, it might be overheated. Now, what might be the temperature distribution of that? Perhaps on that there may be a slight breeze is happening. So, certain kind of boundary conditions are there. Now, if I would like to understand such kind of problem, what I have to do is, first of all, construct an engineering drawing based on where exactly chip is located, where resistor is present, and what are the other components involved on that, what kind of boundary conditions in terms of temperature field I have to apply, these kind of things I have to make it on certain object. And those information we have to teach it to the computer at each and every point. And for that purpose, usually these wireframe designs or drawings will be helpful. The other one is surface models. These surface models are mainly used for visualization of the fields, and they remove any hidden lines of that object. You would like to visualize an object or perhaps the temperature distribution on the surface. Instead, though we supply wireframe model which solves the equations at those points, but your surface information like a colorful contour of temperature distribution or electromagnetic field, what you are going to see, that gives a nice appeal by these surface models. Though information is available at discrete levels at 1 point, 2 points, maybe hundreds of points, but there should be a reconstruction supposed to happen from point to point. So, any surface modeling concept involves such kind of interpolation from the discrete information. For example, this car body, whatever this we are looking at, it looks nice to eyes, but the essential information about color contrast or perhaps the curvature of that object, these kind of things are available at discrete information. Using those discrete information, we go with rendering techniques, try to construct a nice appealed object. That kind of process what we call surface modeling. And these surface models, they do not have any thickness, they are infinitely small in thickness. Their length, breadth, height, these kind of things matters, but not the thickness. If we have such kind of objects, we call we construct it using surface modeling. There are certain objects where thickness or the other dimensions are also important. For example, there is a gas turbine, perhaps maybe for a jet engine, you might be having something like turbine blades, compressors and nozzles, fans and other kind of things are there. Some of the parts are surface, like fan blades, these are having zero thickness, but some of them like nozzles and perhaps the shaft of that object, these are three dimensional things. So, a detailed view, if we are going to provide such kind of things, what we call solid models. Though all are three dimensional, in terms of computer graphics, the representation, they will be categorized as wireframe models, surface models and solid models. If you are going with solid models, it requires enormous or gigantic computer memory. You have to store information at all these points. Surface is in between wireframe and solid models. So, let us look in detail about these wireframe models. Usually, any three-dimensional object, if we are going to connect it by wireframes, that means we are going to identify something like vertices and something like edges. For example, if I want to represent a cuboid, in the wireframe model, what I require is something like vertices. These are the vertices. And we require certain more information like data structures, which are these vertices connected with each other, linked. If we know that information only, we will be in a position to represent these two supposed to be connected by these edges, these supposed to be connected by those edges, these connected by that edges and further. So, there is a proper data management one has to do with that. So, in wireframe model, we do not show this kind of hidden lines. But it contains vertices V and these edges. Any three-dimensional object we would like to represent, these are the minimum information we require it to connect it. Now, if we are not careful in terms of tracking these nodes, vertices, edges and other kind of configuration, the same points may give us a misleading information also. If we are not in a position to carefully connect these information, maybe this one goes there, this one comes there, this one comes, and it will be a complicated picture we will be having, which might be observed also. So, when we are using wireframe models, these vertices, edges, their links, the hierarchy has to be carefully followed. Usually, these wireframe models contain information on planes such as the size and orientation, something like whether this surface is oriented by 40 degrees, 50 degrees and so on. and all this information is related to set of edges. So, we always be having edges, something like this is one edge, other edge, and this one is another edge, and so on. So, set of edges always be there, and these edges usually intersect with each other to make it a 3-dimensional object. And usually it is not necessary that we have to connect these vertices only by lines, they can be connected by curves also. Here we have such an example, cylinder. If these are the points what we are defining as edges, then we can construct by arcs also. If I repeat similar kind of objects, perhaps I will be in a position to construct 3-dimensional shapes. For example, if I would like to have something like a very long pipe, then we will have that kind of cylindrical elements, many connected line by line. If we have a pipe bend, then again some part of that cylinder portions, some other things by other kind of curves and arcs, we will be in a position to connect it. On overall, the wireframe model always consists of coordinate values of vertices and what are the vertices associated with particular edges, and are there any faces forming from these edges. These are the most important information. Now, when we are looking at these edges, vertices, careful database structures one has to construct. There are different kind of operations or perhaps combinations one can use. One of them is relational operators, where a set of lists and arrays we will use it to store something like what are the vertex list, something like V1, V2, V3, V4, and then something about edge list, what are those vertices connected with each other so that it forms an edge. Though here this 0 0 1 0 0 0 1 0 0 0 1, it may be forming a cuboid. To teach it to the computer, we have to store not only that vertices information, but a information which are the two vertices connected with each other. So, here for 4 vertices we have a combination like 1, 2, 3, 4, 5, 6 combinations we have. Is a combination in between 2 pairs from out of 4 we have to construct. That is the way we teach it to the computer or store it to say that it is of that particular cuboid. Similarly, there will be tree structures one has to be careful, something like what is the object, which surfaces are connected, and each surface how many edges are there and in that edges which are the vertices, and in those vertices what are the xy information. So, a detailed hierarchical structure one has to go with that. So, there your basic programming concept comes into picture. Sometimes defining class is also useful concept for this connecting these points. And also a network will be involved when you are connecting these points. For example, data pointers naturally come into picture, something like a surface that is having edges E1, E4, E6. So, to construct E1, perhaps you might be using 1 and 2 points. So, these are naturally connected as a pointed variables. Usually, each vertex has 3 coordinates x, y, z, and each edge is delimited by 2 vertices. If I am saying something like edge, both the ends supposed to have these vertices, and usually minimum of 3 edges must intersect at each vertex. Something like if I am saying this is the vertex, perhaps there might be one edge, another edge is coming, another edge is going. That way a network will be constructed. Even to define something like a face, you require 3 edges. For example, here we have a triangular face. This is the first edge, second edge, third edge. Maybe the vertices are V1, V2 and V3. As I said, these wireframe models are low dimensional representation of a 3-dimensional object. This is the minimalistic way one can really represent 3D object. It has its own advantages, like when you are loading the geometry or perhaps analyzing the geometry or perhaps post processing the geometry, not only in terms of view, even for engineering design perspective. These wireframe models are easy to load it on computer and clear the memory also. They can be quickly and efficiently convey information, and we will have multiple views also we can easily construct. Any lines what we are seeing, these supposed to be intersection of surfaces. That means we have idea about what are the surfaces connected with each other. For any continuum analysis like designing the objects, one of the popular numerical method what we call in engineering finite element analysis, these wireframe models are the beginning step to analyze the data. Even these days people use computer controlled machines, CNC machines. This kind of machines for which one can straight away supply these wire models information. So, required operations like turning and other things can be easily formed. Any higher order models we would like to construct, wireframe is the basic step. They have certain disadvantages also. If we are not careful with this list, which edges are connected with each other, it is not so easy to identify what kind of 3D object we are looking at. For example, let us look at this. We have, these are the vertices. In case only these data points, vertices are available and there is a mismatch in terms of vertices which are connected with each other like edges, then the object may be represented in that way, it might be represented even in that way, and it can be represented in that way also, or any other object which might be observed. So, one has to be careful in terms of using wireframe models. So, there always be ambiguity in terms of surface construction, and it does not define anything about volumes and surfaces of the object. Usually ambiguity or hard to guess or interpret is difficult. And they do not have any ability to determine computational information such as the line of intersection between two faces or intersecting models. When you have 2-3 models which are intersecting with each other, representing these curves, contacts becomes slightly difficult. Now, we will look at other object named surface model. So, we learned about there are three varieties, one wireframe model, surface models and solid models. So, now we are going for this surface models. A surface model represents skin of an object. These skins have no thickness or the material. And usually these surfaces we define it by mathematical functions. We use parametric variation to define something as a surface. And this surface models eliminates any ambiguity or non-uniqueness present in wireframe models by hiding lines or not seen. And better visualization and rendering is possible only on surface models, and the objects looks more realistic in this network. For example, like mold designs, die design, this kind of things can be easily constructed by these surface models. Even complex free formed surfaces like ship hulls, aeroplane fuselages and car bodies, we can use these surface models. And anything about roughness, color, reflectivity, we can easily assign it on surface models. This concept of wire models came around 1900, when people try to look at finite discretization and try to understand that, represent the surfaces, connect the surfaces to recapture. People used to go with these dots like wireframes. Then around 1930s, 40s, people started looking at something named surface models because they are more interested about knowing drag, lift on the objects. For example, here we are showing an aircraft. What should be the surface? Because there always be internal, the olden days aircraft always be having internal structure, on that you will be covering it with surfaces. Now, how that surface supposed to be turned on that aeroplane such that one will be having less drag and more lift on that object, because earlier day construction were not on using typical composite materials. So, they have to deform the object in a nice way, and that is supposed to be supported by the internal skeleton structure. So, deforming, riveting, this kind of process requires surface information, and entire surface modeling concept actually came in those days, 1940s. And the way they developed further, using parametric variations, especially by Kuhn's way of surfaces, which we will learn about later classes. There are different kind of surfaces like Bezier surfaces, spline surfaces, and in some sense the ambiguity in terms of intersection of surfaces will be removed by these Kuhn's surfaces. So, where parametric information about curves we will use. That means, there might be a curve, there is another curve, there is another curve, there is another curve. How to join these curves to represent something like a surface? That is the way this entire surface modeling works in the parametric variation. Especially this kind of surface modeling is used for shells, like bullets, you would like to really see it on that shell, outer shells, or domes, that kind of objects, car body panels, aircraft fuselages, maybe the fan blades, the twisted fan blades, and perhaps wind turbine blades. This kind of things have surfaces, a complicated surfaces. How to really make that kind of things requires surface modeling concept. And they are widespread in terms of shipbuilding, and the other one is shoe industries also is quite popular. If you are looking at mechanical industries, the forging and casting operations usually involves these surface modeling principles. We popularly use a word named CAD, computer aided drafting, and also computer aided designing. This kind of concepts requires surface construction. There are computer packages which are available to construct that, and what we will learn is how these softwares, the background of those softwares really works. So, first begins with construction of curves, which we call splines, from which 3D surface is then swept or meshed through. Something like, if I want to make a pot, the essential information what I require is something like a curve, and I might be requiring something like an axis. If I revolve this entire spline around this one, I will be in a position to construct a cup. It is a surface what we would like to construct it, 0 thickness. So, using these kind of splines, one will be in a position to construct it. So, there will be a computer program where we will define based on the points. So, the softwares what we are going to learn is, when you are going to touch the screen or perhaps click the point, your front end takes that information and send it to your back end of that programming, takes that edges, vertices, connect it, fits something like a spline, then it asks you information about which axis you would like to really rotate, asks you for those points, you pick that, then it revolves and construct these objects. So, there will be a lot of information goes at the background, and the front end what we are going to learn in next classes. The other method is directly construction of surface by manipulation of the surface poles and control points. Especially surfaces are categorized into planar surfaces, other one is cylindrical or conical surfaces, and sculptured surfaces we call. If it is a planar surface, the back end how it works is a plane surface that passes through 3 points P0, P1, P2 is given. When you are constructing surface on computer, perhaps we may have to give points P1, P2, P3. X, Y, Z coordinates, either we type it using stylus touch the screen, or perhaps with mouse click on that surface, where we will give X, Y, Z information. Once we have that X, Y, Z information, it will construct at the background a parametric variation P of UV. Any point on that surface can be interpolated using information of first point P0, second point P1 and third point P2, because we want to construct surface from these vertices. So, once vertices are known, a surface which pass through these 3 points can be constructed using such kind of parametric variation. And we would like to, because it is a surface, it might be having a curved shape. So, normal vectors are also important. It might be a planar kind of surfaces, it might be slightly curved kind of surfaces, or perhaps the orientation of that surface also we require. So, normals of the surface also we require, but we have only information about 3 points. We do not know complete information about surface which we are intended or interested to construct. So, in that case we again use normal vector in terms of P1, P0, taking a cross product with P2, P0 points. Similarly, P1, P0, P2, P0 cross products we will construct. By using that, we will be in a position to construct what might be the normal to surface. Based on that color mapping we will do. And in the next classes, we will learn more about surface models and different kind of spline surfaces. Thank you very much.